Okay, so this is lesson 7 for group 1, which is going to deal with markup and markdown problems. We've done in the last couple lessons very similar problems to this, so there's not a lot new to go over, but definitely practice is a good idea. So let's get started. It says a video game markup. Games Galore Superstore buys the latest video game at a wholesale price of $30. The markup rate at Games Galore Superstore is 40%. You use your allowance to purchase the game at the store. How much will you pay, not including tax? So first of all, it says write an equation to find the price of the game at Games Galore Superstore. Explain your equation. So for this, we want to write just a single equation that is going to get us the final answer. So go ahead and write your equation on your paper or in your book, and then we'll continue. Okay, so if you completed the equation, it should look something like this. All right, so we have $30. I've basically got rid of the cents for now because the cents are really not going to do anything. 30.00, you're going to get the same when you multiply it out. And we have 140% because it is a markup. We discussed this in the previous lessons, how if you have a markup, you want the price, which is the $30, you want 100% of that plus an additional 40%. Now you could go ahead and multiply 30 by 40% and then add that to 30. But if you're going to be working backwards, which you will be in these problems, you're not going to be able to do that. So whenever you see a markup, you know that you're just going to have to add that 100% to the percentage. Okay, so the next part B says to solve the equation from part A. So go ahead and solve this and get your final answer. Okay, so you worked out hopefully just a simple multiplication problem, remembering to change the percentage into a decimal, and then just multiplying it out, and you get F equals 42. Okay, next part, it says, what was the total markup of the video game? So what was the markup? Go ahead and write your answer for that. Okay. Sorry. So what was the total markup of the video game? The markup was $12 because the price with the markup is $42 and the wholesale price was $30. Just a reminder that the wholesale price would be the price that the store would pay. The retail price would be the price that you would pay at the store purchasing the item. Okay, so the next question is just kind of a thinking problem. So suppose you just write your answer for that. It says, you and your friend are discussing the markup rate. He says that an easier way to find the total markup is by multiplying the wholesale price of $30 by 40%. Do you agree with him? Why or why not? So go ahead and just write an answer or think an answer out really quick for letter D, and then we'll move on. Okay, so to answer this, in order to find the total markup, multiplying the wholesale price, $30 by 40%, it would give you the markup. Is that the easiest way? I suppose, unless you want to subtract the retail price from the wholesale price, that would work as well. That's definitely not the best way to get the retail price or the price that you're going to pay. It would be much easier to multiply it by 140%. Okay, so let's get on with example 2, which is Black Friday. It says a mountain bike is discounted by 30% and then discounted by an additional 10% for shoppers who arrived before 5 a.m. It says find the sale price of the bicycle. Okay, so first thing we do is find the sale price, and then we're going to find the price if you shop before 5 a.m. So there's two different problems here. So find out what the price is with just the first discount, and then we'll go ahead with the second part. And again, try to do this in one equation. That's really important, is that you solve this without using secondary work, because when they're giving us problems to work backwards, you're going to need to be able to do that. Okay? So write your equation and we'll continue from there. Don't go past that, because if you make a mistake, it doesn't seem any point to keep going. So write your equation, then continue. Okay, so remember we were talking about percentages in the previous lessons. It says $300, the bike is discounted 30%. It's discounted by 30%. So if you went ahead and multiplied 30% times 300, that would not get you the sale price of the bicycle. And this is what I was talking about before I told you to write down your equation. You do not want to use 30%. That's just going to get you the discount amount. 30% is the discount percentage. So if you multiply the whole times the discount percentage, all you're going to get is the discount amount. You want to get the sale price. It would be different if they asked you how much of a discount are you going to get, and that's something you have to be aware of when you're doing problems, is which number are you given. If they give you how much the discount is, then you would use that to work back in order to get the total amount or the whole price of the item. But because they want the price that you're going to pay, the sale price, we do not want to use 30%. 30% will get us the discount amount. We want the amount you're going to pay. So if you're going to get 30% off, what percentage are you going to pay? And as you see over here, the answer would be 70% or 0.7. I already put it into a decimal form. So it's 0.7. Because 70% and 30% is 100%, which is the total price of the item. So instead of multiplying it by 30 and then subtracting, which is two different steps, you just multiply it by 0.7, do that in your brain, and you would get $210, which makes sense. That's what you would pay at 30% off. Okay, so part B, it says, in all, how much has the bike been discounted in dollars? Okay, well, we can answer that one without doing a pause. So the original price of the item was $300, and you're going to pay $210 with it on sale. So the item has been discounted $90. Okay, now it says, after both discounts were taken, what was the total percent of discount? Okay, so this one is a little bit more complicated. So what you're going to have to do is, so they said 30% discount for the sale, but then another 10% off if you buy it before 5 a.m. or something, I believe. So our price right now, the sale price is $210. And now we need to take another 10% off the price of the bicycle. Okay, so that's the next step here. That's letter C. So we have to figure out what the price of the item is so that we can figure out what the percentage of the discount is. Okay, so go ahead and write your equation to find what the price is with the additional 10% off. Okay? Okay, so hopefully you were paying attention to what we did last time. Once again, it's 10% off. We want the price you're going to pay, not the amount of the discount. So, once again, we flip the percentage. 10% off means we're going to pay 90% of what's left. So the price of $210, we want to take 90% of that because that's what we're going to pay, and that's going to equal our sale price or the discounted price. So I did the multiplication off to the side, and we get $189. But that is not the end of this problem, because now we need to figure out what is the percentage of the discount. What percentage, it's getting out of focus, what percentage is this of this? So what percentage of this is this? And you can kind of hear the equation when you read it that way. We want to know what is the total percentage of the discount. How much is this been discounted? It's not 30%, and it's definitely not 40%. Don't just assume you can add those discounts together. That's not how that works. You actually have to do the math here. So we have $300. That is our original price. And we want to know what percentage of this, so times what percentage, is going to equal our $189. Okay? So from here, algebra is pretty obvious. Go ahead and work that out and continue the video when you are ready. Okay, so if you completed the problem, should have divided by the 300 on both sides. Division's way over here, so add the decimal point, you go 2 places, that makes sense, and you get 0.63 or 63%. So that means that this number, 189, is 63% of 300. And again, that's not the end of the problem, because it wants to know what is the percentage of discount. We know that this number, 189, is 63% of 300. So what is the percentage of discount? What percentage discount did you get of the $300? You're paying 63%. So what discount did you get? And again, you just use the opposite of that percentage. So 63% you are paying, so what percentage are you getting discounted? It's 37%. Okay, so let's keep going. Question D. It said, instead of purchasing the bike for $300, how much would you save if you bought it at 5 a.m.? Okay, that's kind of a simple problem. So the original price was $300. The price after the additional 10% was $189. So you just simply do the subtraction. That's a pretty simple problem. So if we have $189 and you're going to pay $300, that's just a simple subtraction there. All right, so let's get on to these exercises over here. So for this one, again, let's just do these one at a time. It's easier to do it with the camera, doing one at a time. So it says, Sasha went shopping and decided to purchase a set of bracelets for 25% off. In case you're wondering, that's the price of the bracelets right there. So 25% off the regular price. If Sasha buys the bracelets today, she will save an additional 5%. Find the sales price of the set of bracelets with both discounts. How much money will Sasha save if she buys the bracelets today? Okay, so you got to do basically 2 steps. You're going to find out what is the price of the bracelets after she gets her first discount, and then find out what would be the price of the bracelets after she gets her second discount for buying it today. And then finally, what is the price difference? How much would she save if she buys it today rather than tomorrow? What is that price difference? Okay, so this is all just one problem. So go ahead and do all of that, and then when you're ready, keep going. Okay, so here is your first setup. So since she has a 25% discount, that means that she's going to pay 75% of the $44. 25% off means you're going to pay 75%. So $44 times 75%, or 0.75. Multiplication's done right over here if you need it. And you get $33. Okay, so it's a quarter off. So then, for the second part, we have an additional discount of 5%. So from the $33, if you have 5% off, that means you're going to pay 95%, or 0.95 of the $33. The multiplication also, again, is right over here. Just multiply it by 0.95, and you get $31.35. So how much is she going to save? Well, if she didn't buy it today, she would pay $33. If she buys it today, she's going to pay $31.35, which means she's going to save a whopping $1.65. Okay? All right, so let's take a look at number 2. And there's not too much more of this lesson left. A golf store purchases a set of clubs at a wholesale price of $250. $50. Mr. Edmonds learned that the clubs were marked up 200%. Is it possible to have an increase greater than 100%? What is the retail price of the clubs? Well, this is a markup, so we're going to mark it up. You definitely cannot have a discount of more than 100%. A discount of 100% would be everything. So let's say something costs $20. If you get 100% off, you're paying zero. You get 20% off. 20% of $20 or 100% off of $20 is $20. So you pay zero. But so it's impossible to have a discount of more than 100%. But can it be marked up more than 100%? Just think about that for a second before we begin the problem. And of course, the answer is yeah, absolutely. The price of an item could be marked up as high a percentage as they want to. Just look at what people are doing with like toilet paper and that type of thing right now, where $6 package of toilet paper is selling for like $40, $50 on eBay because people are having trouble finding it. You could mark it up wherever you want to do. You could mark it up 10,000% if you wanted to. But it's important to remember that since this is an increase of a markup, so the wholesale price, what the store paid, is $250. They're going to mark it up 200% above what they paid for it. So go ahead and figure out what the price of the golf clubs are if it's marked up 200%. Okay, so once again, we have a markup. And remember that the markup, we want it to cost $250. If it costs exactly what it would cost, it would be 100%. That's not a markup. That would be 0% markup if we paid $250. We want to increase it by 200%. And again, we keep going over these types of problems. The easiest way to do that is to always just add that 100% in. So when you had your equation, which is $250 times 300%, because 100% would be even. If we multiply it by 200% or just put 2, that's not going to be a 300% increase. So you have to add that extra 100% when you're doing the problem. Okay? And this was pretty easy. You're basically just multiplying it by 3. So then you get your answer, which is $750 for the clubs. And again, you could do it again. You could do it by 400% or 300% and get $1,000. You can mark up anything as much as you want. There is no limit. Okay, so is a percent increase of a set of golf clubs from $250 to $750 the same as the markup rate of 200%? And we just answered that. We talk about that a lot, and the answer is no. The percent of increase is 300%. Because markup just kind of implies that it's going to be at least the price of the original item. So in a markup of 5% would not be 5% of the item. It would be 105% of the item. So hopefully that's making sense to you as we're doing more of these problems, that when you get a markup problem, you always add that extra 100% in. Okay? Let's move on. So working backwards, this is kind of what we were talking about, or I was saying is going to happen. So it says a car that normally sells for $20,000 is on sale for $16,000. The sales tax is 7.5%. We'll worry about that later. What percent of the original price, so hear the equation when you're reading the problem, what percent of the original price of the car is the final price? Go ahead and write out your equation. Okay, so hopefully you have this, the original price, which is $20,000 times P. And again, you might have reversed it because it does say what percentage. So you could do P times 20,000. It doesn't make a difference since it's multiplication. Is equals 16,000. Okay, so the next one says they want to find what is the discount rate. So this is what you're going to pay. So $20,000 times this percentage is going to give you what you're going to pay. What you want is how much are you not going to pay? What is the percentage off of the discount? So go ahead and try to figure that out on your own. You could use this equation. There's also a different way you could do this. You could also find out what the discount is, meaning you take 20,000 and you subtract it from 16,000, you get 4,000, and you could figure out what percent of 20,000 is 4,000, and that would give you the discount percentage as well. This one requires one extra step, but both of them will work. So basically, what I'm saying is you would take 20,000 is what percentage of 4,000. Now, this is the discount. So since this is the discount, we will get the discount percentage. What is the percentage of discount, or the discount rate? This one, because this is what you're paying, is going to give you the percentage you're going to have to pay. And then you would just use the opposite percentage of that to get the percentage of the discount. So if you're going to pay, let's say 20%, then you got an 80% discount. Okay, so go ahead and solve this problem out. Either way, I'll do both so you can see both. Okay, so if you did the first version, you would have got divided by 20,000 on both sides. You would have got a percentage of 80%. But that's not the final answer to the problem, because as we said, that's the percentage you're going to pay. In order to figure out the discount amount, you have to use the opposite. Out of 100%, if you're going to pay 80%, then you got 20% off. And that would be the answer to this problem. Now, if you did this version, so we used the two values. We used 20,000 subtracted 16,000 to get the amount of the discount, which is $4,000. So if we work this one out, divide by 20,000, we get 0.2. And this immediately, because this is the amount of the discount, we get the percentage of the discount. If we have the amount you're going to pay, you get the percentage you're going to pay. So just pay attention to the words when you're doing your homework assignment, and it should be pretty simple. Okay, let's go on. So we did the discount amount. It says, by law, sales tax has to be applied to the discount price. However, would it be better for the consumer if the 7.5% sales tax was calculated before the 20% discount was applied? Why or why not? Okay, so what you're going to do, so for this one, you're going to take your discount amount. So we already did that. How much you're going to pay? We pay $16,000. Should we charge 7.5% sales tax before the discount or after the discount? Okay, so to do this, or you're going to do this two ways. So take your original or the discounted price, which is $16,000, and you're going to multiply it by the sales tax to figure out what the price is plus sales tax. Then with the regular price, the $20,000, you're going to multiply that by the sales tax, and then take the 20% discount and figure out which one is better. Okay, go ahead. Okay, so this required a little bit of work here, a little bit of more computation, but basically here I took the 16,000, which was our discount price, and multiplied it by the 7.5%, which got us $1,200. Added it to the 16,000, got 17,200. Over here, we did 20,000, and then I added this, or multiplied by the sales tax, which got us $1,500. Added the $1,500 to 20,000, got 21,500, and then took 80% because of 20% discount. That means you're going to pay 80%, and you get 17,200. So you get the exact same amount. So it does not matter, because in multiplication, it doesn't matter what order you multiply everything in. Okay, so we're going to skip D, and we're also going to skip the table part. That doesn't really Too much of anything to worry about that now. So get on to exercise 5, which is our last exercise here. It says, use the following table to calculate the markup or markdown rate. Show your work, is the relationship between the original price and the selling price proportional or not? So this is a nice throwback question to the ratios we did early on. So are these values proportional? Meaning, do you multiply or divide by the same number to get the number on the right? Figure out what the percentage is, and then explain whether it is or is not. Okay? So this one, you have to check pretty much every single number that's up there. If you find one that is not proportional, let's say the first one is a 20% discount and the next one is a 40% discount, well, then it's not proportional and you don't have to do any more. But if you find that the first two are proportional, you still have to check to make sure the bottom three are. You have to check every single one. So it's actually faster if you find that it is not proportional early on. So go ahead and do your check and see what you get. Okay, so they're looking at the original price. The original price is $1,750. The selling price is $1,400. So if the original price is $1,750 and the selling price is $1,400, you should be able to tell just from that it is going to be a markdown. Now the question is, what is the markdown rate? What is the percentage of the discount? So not what you are going to pay. What percent of $1,750 are you paying of $1,400? It wants to know what is the discount amount, the percentage. So if this was on a sign, what percentage off is all these prices? And just so you know, yes, they are all proportional. So they all basically follow the same amount of discount. And the discount would be 20% for all of these. Okay? All right, let's go look at the problem set for today. These problems, for the most part, just read them very carefully. There's not a lot of difficulty. Again, if you have questions, make sure you're posting them. Be specific to which problem. Don't just write, I don't get it, because that's, first of all, that's not even a question. Okay, so definitely be doing your own work. You're going to be finding that there are going to be quizzes on the off days for math. So any day we don't do a regular math lesson, we're going to start doing quizzes like we did or would if we were in class. Get grades in for that. Part 4 or number 4 you can totally skip. We're not worrying about graphing at this point. And 5, 6, and 7. Some of these problems will require you to do more than one step. Again, make sure you are doing your own work. Make sure you are completing the problems. And since we are doing, or you'll be doing this over 2 days, so this is assigned, actually, since this is assigned on Thursday, you're going to have till Monday to do this. So go ahead and you're going to complete all the way to 17 with the exception of number 4. Okay? So that's the end of this lesson. If you have any questions, write it in the comments or post it on Google Classroom, and I've been trying to get back with it as soon as I see them. Other than that, have a good day, and next lesson will be on Monday.